Hello, Internet! Today I want to talk to you about how to make money with large language AI models. And we have here a press release by NVIDIA, a small company that is about to train some models. As I already showed you, the Megatron 530B was the topic in my last video. And now, of course, you have to deploy the model. And the idea here is, let's download this image here, that you have the Megatron model here running on a very particular supercluster from NVIDIA. You have your customer data, you have your specific data, your domain-specific knowledge data that you want to have integrated, and you want to have, after some distributed training on the supercluster, a custom-specific, a client-specific Megatron 530B model. This means your personal pre-trained and optimized AI model for your business case. And then, of course, at first you have to train this for your particular customer insights, and then you have to deploy these models. And you will not guess, but NVIDIA is here to help you, and they provide the hardware and the software for you. So for the deployment, they have, where is it? They have their Triton inference server, and you can run this just on 2 NVIDIA DGX systems. And I already showed you, this is for the open source Triton code. The DGX is here. And as we already discussed in the last video, it consists of n NVIDIA A100 Tensor core GPUs, each with 8 gigabytes of memory. So in total, we have 8 times 80, 640 gigabyte of total GPU memory. We have the switches, we have a Gen 4 NVMe SSD, and of course, we have a 64 AMD RAM CPU integrated in this little package. And this little package is a new building block of the AI data center, NVIDIA DGX A100, the universal system for infrastructure. And this video is not sponsored by NVIDIA, unfortunately, because this channel is just so small and insignificant that NVIDIA doesn't even know about it. But I want you to know about the possibilities that technology opens up for all of us. So, this was the inference server software. I talked to you about the hardware elements, and now let's talk about the costs. Now, interesting here is, and this is here an article from VentureBeat from November 9th. Oh, everything is November 9th, 2021. And they make massive language models available to enterprises. Yes, of course. And we have again here our Megatron 530B model. This has now been trained on an NVIDIA supercluster. It has been adapted and fine-tuned to your domain-specific knowledge, to your client-specific tasks. And then, of course, you have to deploy the system. Now, if you can run it on the infrastructure, you have 2 options. You can buy the infrastructure, and a SuperPOD can cost anywhere from 7 million to 60 million, depending on the depth of your pockets. But of course, you are lucky there is a subscription service that is substantially cheaper, and a SuperPOD runs for $90,000 per month. So you can see how significant the investment is here if you really have the LLMs, you train an LLM for your company, and then you deploy it. But if you think that this is the end, we have here a statement that it is entirely possible a company will invest $1 billion in compute time. Again, $1 billion in compute time to train a model, an English LLM, within the next 5 years. And they say that there's a study from the University of Massachusetts that taking an average image recognition model with 5% error rate would cost around $100 billion. Now, this is absolute nonsense. I mean, technology has to advance much more before you can really apply it on a commercial level. But it is interesting to see that companies do invest these monies and that there is some advancements. Yes, so it might be cheaper. That the cost of running GPT-3, the old GPT-3 costs running it just a minimum of $90,000 per year. So this is cheap crap, but yeah, of course, bias and whatsoever. But what's really interested is the integration, because what we have is just a large language model. And it is a natural language model, and more or less a machine understands and can communicate with other human beings. But how you integrate it in a bigger ecosystem. And NVIDIA here is presenting us with another press release that they have significant components in their ecosystem, if you want. You have perception capabilities. This is a computer vision framework for video analytics. And so they can record what a camera sees if you're standing in front of a desk, if you're having some interaction. Then you have, of course, the speech recognition system from NVIDIA. And then to start a natural conversation, you have the Megatron 530B, the large language model that recognize, understand, and generate the human language. And then you are not limited just to output a human language, but you also have an avatar technology. And this is powered, as they state here, by NVIDIA audio to face. And this is a two-dimensional and three-dimensional driven facial animation and rendering technologies. So what you have is a communication platform, more or less, where you have speech recognition. You understand what they are telling you. You have a perception engine, a computer vision framework for video analytics. You can see what they do. Then you have a model, a language model, so you can communicate, understand, and generate human language. You have the discussion. And then as an output, you have an avatar animation, a two-dimensional and three-dimensional AI-driven animation rendering technology. Something that is able to interact with you. Maybe you know avatars from games, but imagine an avatar if you enter a clinic. Imagine an avatar if you have a telemedicine conference, a telemedicine call, and an avatar is checking the first parameters with you, interacting with you with a human language, with a very general human language, not in a specific Latin way or whatsoever. So these are significant application of this technology. And today I just wanted to show you that one company, and I refer here to the press releases of NVIDIA, they are working exactly on this technology from perception, speech recognition, LLMs, and finally to avatar animation to really provide a virtual communication interface where you have with your natural language, you can interact with. Imagine a business case in homes for elderly people. They are often lonely and they need someone to talk to. And I know I've been in Japan and I've seen some robotic application already being applied there in the homes for the elderly. And I think there are so many business cases out there where you integrate this technology, it can really change the life of people. But, and let's make it clear, currently we're in the domain of supercomputers to be able to have a real communication. And just to show you this, I would like to leave you with here a statement from CityNet, and this is the Vice President of Deep Learning Research at NVIDIA, saying that building LLM models for new languages and domains is likely the largest supercomputer application yet. And now these capabilities are within reach for the world's enterprises. Well, depending if you're a very, very successful world enterprise, if you're a global player, I hope for you that you can afford this. But it is also interesting for data scientists to understand what is coming up to us, what will be the new application, what will become new products, how our ecosystem will change if those capabilities will not be limited to the largest supercomputing application, but they will trickle down to normal cloud clusters people can afford, enterprises can afford, hospitals can afford. And I think it is fascinating to have some basic knowledge about LLMs, large language models, how you can apply them, how you can train them, on what hardware you can train them, on what server software you can deploy them, what are their benefits, what are their disadvantages combined with their advantages, and to program, to code some application cases is absolutely interesting for me. I hope I provided some new ideas, some new information for you, and I see you in the next video.